Hello students, today we're doing 5.3 activities in class, and if you follow along with this is what we will be going through during class. So why don't you start by trying the warm-up, pause the video, and then unpause it when you are ready for the answers. So what you can see here is to find the slope from a table. We did change in y over change in x. So we did 7 minus 9, negative 2 minus negative 3 to get negative 2. So that's our slope. To find the y-intercept, we look at where is our x value 0, because we don't want to go left or right at all. We just want to figure out where we're on the y-axis. So our y-intercept here, our b value will be 3. To write the equation, we've been dealing with y equals mx plus b here. And so we fill this in. Y is equal to our slope, negative 2x, plus our b value of 3. So like I said, 5.3 is linear function patterns. Our essential question is, how can you use a linear function to describe a linear pattern? The question we're going to be answering today and at the end of the lesson is going to be, why is the graph of a linear function a straight line? So activity 1, go ahead, pause the video and see what you can get for this one. Hopefully you got that the slope and the y-intercept, those are our math words. Now figure out what could a real world word be, and then what can an example be of slope and y-intercept. So here's the table filled out. Slope in the real world, we wouldn't say slope, we would usually say rate of change. So the slope is considered a rate of change, which an example would be something like miles per hour, how fast you're going. If you're going at a constant rate of change, your slope is the same. So that's why we're getting that straight line, because of that rate of change. Y-intercept, we could say, is like the starting value, where you begin, the start. An example in the real world would be like the initial payment that you put into your bank account, or the initial payment you make on the phone bill would be like your y-intercept. Next activity, you are doing a matching activity. So go ahead, look at the equations and look at the graphs and match the equation to the correct graph. Take a minute, try this on your own, pause the video. So here are the matches. 1 goes to C, 2 goes to A, 3 goes to D, and 4 goes back up to B. Some of the things that we are looking for, remember that B value here, the end number, what we're adding, that's your y-intercept. That's where you're crossing that y-axis. I noticed this graph 1 crosses at positive 4, so it was either going to be C or D. It has a positive slope, so that's why it is C, a positive 2 slope. Okay, looking at number 2, we have a y-intercept of 1. This A is the only one that has a y-intercept of 1. It also has that positive slope, positive 1/2 slope. Okay, so we looked at the y-intercept. We looked at if it was a positive or negative slope to match those. Activity 3, go ahead, pause the video, read through the example. You're given a table here. And now remember things like rate of change. What does that mean? And that's the real world word. What does it mean in math words? What's the initial calories burned? What's the math word to find for that? And then write the equation for this table. So pause the video, try it on your own, read through the problem, and see what you can get. All right, so let's walk through this problem here. So first, how many calories are they burning per hour, or the rate of change here? That, remember, is your slope. Rate of change is the slope. So we do change in y divided by change in x. So 1950 minus 0, 3 minus 0. You get 1,950 divided by 3, which is 650. So the slope here, or the amount of, they're burning 650 calories per hour. What is the initial calories they burned? Well, that would be our y-intercept, that initial part, the starting, or where they began, and that's where your x value is 0. And so right here, we're starting at 0 calories. So your y-intercept is 0 calories. Now let's think about this. In terms of this problem, why are we starting at 0 calories? Well, they haven't done any climbing yet. They've done 0 hours of climbing, so they haven't burned off any calories yet. So that makes sense that your starting value or your initial calorie burn is 0 calories. So therefore the linear function or the equation would be, again, y equals mx plus b. Y is equal to slope 650x plus our y-intercept of 0, but we don't actually have to write plus 0, so your more correct answer would be y is equal to 650x, and that's just your answer. Now, in summary, it says, why is the graph of a linear function a straight line? So let's think about that. We talked about this a little bit when we started talking about rate of change. And so we know that slope of a straight line is the same thing as rate of change. And it's a straight line because it has a constant rate of change. You're consistently going up and over, up and over, up and over. You're creating those stairs to create that straight line for our graph. So next one, which of the following are not going to be a linear function? So which ones are not going to be a straight line? Well, we know that y equals mx plus b is our straight line, so that one's good. We remember, if you can remember, this was our point slope form. That one is also good. This was also point slope form, so that one's good. We know y equals 3 is a horizontal line, so that's a straight line. But these other ones, we haven't really talked about what it means to have an exponent. These ones have exponents on there, so these ones are not going to be straight lines. All the other ones, those are straight lines. So that is it for 5.3 activities. Have a good day.